Check, check. Testing. All right, guys, I think we're about ready to get this started. Let's do this. I'm just finishing up my setup here. Work. All right, hey everyone, how are you guys doing? All right, give me just a minute. I'm setting this up. It's gonna be really interesting because I have no idea what's going on, and you guys are gonna be along for the ride. It'll be pretty cool. So what I have here is a 120 volt lighting fixture, and it's currently failing. I've got a couple of the LEDs that are lighting up fully, and I've got most of them are dim, some of them aren't illuminated at all. And we're going to be troubleshooting AC and DC, and this is going to be very indicative of what you're going to see on medical devices. So I figured, why not? Let's take you along, show you how to do it, and I'm even going to show you how to do it safely. All right. So tell you what, let me see if I can trigger my camera to. I have a new overhead camera here, and it can do some pretty cool stuff, guys. I have it so it can do AI, and it will auto follow things that I tell it to follow. Tracking lock. Tracking. Hold on, I've got to switch my video feed so that I can select the object I want to track. I think my cell phone right there in the middle, my old cell phone anyway, is going to be a pretty good item to track. Let's try it. Hold on one second, guys. Here we go. Switch you all over to a different camera feed so I can hop in. It's funny how cameras work on computers, because you can't have it active in two windows at once. That's why I have to like disable you guys' view for my overhead cam. Let's see, animal, human tracking, object. Okay, AI. All right, okay. We can disable the preview. And let's go back into it. Okay, so now what should happen is I will move an object like this and see how the camera follows. This is kind of cool. I think I'll create like a target, and I will put a target on here later. So if I want to move around and show you guys what's going on, I just move that object or that target around. I'll come up. Maybe it'll be like a Better Biomed sticker or something. I don't know. I'll figure it out. But for right now, it's going to be this experimental old cell phone that I've tortured in so many of my other videos. Okay, guys, so let me go ahead and make this window prominent so I can see what y'all are saying and doing. Okay, so this is the lighting fixture. It's currently upside down, and I've got my 120 volt mains right there. Let me disable the preview. You guys don't need to see me right here. You know what I look like. Let's go ahead and disable that. There it is. Now you guys have a better view of what I'm doing. Okay, so right here is my 120 volts. There we go. Here, let's move this guy right there so the camera's tracking me. So right over here, I've got a isolation transformer. You can see it right here. It's a toroidal transformer, and it is not currently plugged in, but this is for safety reasons, because we are going to be dealing with open mains right here. This here is going to make sure that this is also very safe. And of course, man, I love this camera. You can see over here that I have, obviously there's going to be some sort of rectification in here, and it's going to switch over to DC. But then what I'm assuming is going on is a couple of the channels right here are defective, because I've got 2 of my lights which are fully illuminated, and I've got 4 of them which are barely anything at all. It's telling me that my power circuit over here is probably bad. But also, all these wires are kind of crispy together right here. And I could definitely get you guys a zoomed in view, but I think you guys get the point. Yeah, wow, those are so crispy. So what we're going to do is we're going to troubleshoot, and we're going to do this proper. So I'm going to measure my 120 volt mains coming in, and then we are going to go ahead and see if we can open this up, measure our DC voltage, because what I'm assuming is that part of my power circuit is bad, maybe part of it's good. We're gonna find that out together, okay? And I do have also, come here, camera. I dig this. I have a regulated DC power supply over here because LEDs will continue to pull amps until they short. You know, they want to act like a dead short, so you have to have a driver for them to limit the amount of current that goes through your LEDs, and that's what this guy's going to replicate. And we're going to figure out what that voltage is. So I have no idea. Normally there would be on many devices some sort of DC stamp that says what the DC voltage is. And yes, it's okay. It's not plugged in yet, guys. It's safe. So I'm looking around for any sort of stamp. Now the only thing I can tell right over here is that it says it's 39 watts max. Okay, so 39 watts, that is not very much. With losses, which this thing does get a little hot, that means that we're probably dealing with like 30 watts divided by 6, and be able to figure this guy out momentarily. Okay, so let's go ahead and let's do this, guys. All right, y'all ready? This could catch fire. I have no idea. Let's do it. I've got my multimeter over here, and we're going to go ahead and we're going to take some measurements to make sure that my toroidal transformer over here is good. Okay. So go ahead and move him right here. Okay. So I have an exposed connector right here and an exposed connector right here. If I plug this guy in, it powers up my isolation transformer. And you can see over here that I have a couple lights right here. These two here look like they're operating at full voltage. I don't know which ones that is right here. I have no idea. We're gonna figure it out. So I am getting some sort of power here. Go ahead and take a measurement just to be sure. It's right here. There we go. We'll work through it. Okay. Measurement here, and here. 126.6 volts AC. And like I said, that is isolated, so it's not going to be the 120 volts that you normally think it is. Isolated power technically means, camera, get right over here. So my input, my primaries on this transformer right here are going to be neutral and 120 volts. And the secondaries, which are coming to a power strip right here, and the power strip is kind of hidden, it's right there. It's hidden, trust me, it's there. So on my secondaries, I should have 60 volts and 60 volts on L1 and L2. So that gives me my 120 volts across, but that means that it's not tied to ground or neutral anymore. So that's why this is a safer condition. Technically, I should be able to touch either one of these when it's powered up, and as long as it's a single fault condition, I should be safe. Now, if I touch both of them, I would expect to get lit. But so I have my 120 volts isolated here in a vise, just safe, weighted down, and now we're gonna come back over here. Let's check this bad boy out. Okay, so we have our power coming in. We've got those two lighted up. So now I gotta figure out what those two are, and we might as well just take this guy apart. And in order to do that, I will be able to zoom in and show you guys step by step what we're doing. So at this point, it's actually pretty safe to go ahead and just unplug this bad boy, because we already know we have something going on probably here in the power supply. Now, it is possible that we do have failures on these LED bulbs. It's possible. But what is the likelihood that these two circuits right here have failed? it's not very possible at all, is it? So it's more so probable that part of my circuitry has failed. So when you're troubleshooting something, always think about what's possible versus probable. And in this case, it's going to be pretty simple to figure out that it's probably going to be the circuitry. Okay, let's see if I can zoom in, get you guys a better shot of this. And this is a new camera, guys, so I am definitely getting used to it. So. Okay, how about that? Okay, we're a little bit closer now. And pull this out so we can take a look. These guys are so crispy right here. Look at that. And normally when I see heat damage like this, that's when I get suspect that, you know, I've got a short someplace. But maybe it's just because they've been compressed together, and shrink tube can do some pretty funny things. So I'm not too concerned with that. And look over here on my outputs. These are my DC outputs over here. Notice there are 3 different sets of wires. And they come down here, and they're all kind of joined together. But there's 3 different wires, which means 3 different sets of wires, which means there's 3 different circuits. Let's go ahead and pull this guy apart. And because this guy is so small, I am definitely using hand tools. It's brittle plastic. I don't know why. I'm a very tactile person. I love using hand tools, unless it's a big job. Let's see what's going on under this cover. All right, all right. Interesting. So I've got what looks like a type of celastic down here, and this coating that they put down here is so that it doesn't move around very much. It helps stabilize the wires, probably during install. Now I've got 3 different circuits here. Let's go ahead and let's zoom in so you guys can see what those look like. Try moving the cell phone over a little bit. Hopefully that works. Now this camera right here is phenomenal. I can zoom way in and show you guys exactly what I'm doing. I don't know if that's going to be completely necessary, but I can do it. Now these are all really small circuits. Oh no. Okay. I can see part of the problem, folks. I can see part of the problem. Now I did a video probably 2 or 3 years ago, maybe 4 years ago now, where I talked about how thermal compounds will dry out, and when they dry out, they will cause items to overheat and fail, semiconductors specifically. And I think that is what's going on here, guys. Okay. Keep all my screws in a spot. So this right here, this is my circuit, but look on the bottom. Not only the piss poor amount of thermal compound they put on there, not very much at all. That contact patch is horrible. Here, let's see if you guys can get a better view of it. Right there. Horrible contact patch. So it really wasn't cooling very well, and it's kind of chalky, which means that it's not good. Not at all. You can see that there's a heat sink, kind of a makeshift heat sink out of some extrusion right there. That's not good. And that could be why it's starting to fail. It just got too hot. Okay, so the first thing that I want to do is I want to separate out these wires right here. We can fix all these back up afterwards, but I've got to separate them. Like this. Goodness, they're all, you can tell it gets hot in here because of how bonded these are. They're glued together. All right, so there's my different channels, And I think what we're going to have to do is we're just going to clip these wires. Those wires are really too long for what they do. So let's go ahead and do that next. All right. Clip, clip, clip. Okay, so there's one channel. There's two channels. And three. Now by clipping these wires, I mean, it's already broke, right guys? By clipping these wires, I now have a conduit where I can test the lights themselves. We can do that with our regulated DC power supply. I don't think the lights are gone. I think they're going to be just fine. And if anything, I might just have to find a replacement power supply. And instead of putting them as 3 different circuits, I don't understand why they don't just put them all on the same output. Maybe form factor to make this small. I don't know. I've got to wipe off this thermal compound because that's going to make an absolute mess over here. All right. Make an absolute mess on my desk. So since I'm not pushing anything, I don't really need this guy to be heat sunk to anything. Doesn't have to be bonded. I can just test it. As soon as I start connecting up a load, that's when I will definitely need heat sinking. Okay, so let's go ahead and we'll take our lighting fixture. I'll move it off to the side, someplace safe. And now I need wire strippers. Okay, so here's what we got. Let's move him over here. Put my fasteners in there. You guys know I will lose fasteners in a heartbeat, right? Okay. Right there's my DC power supply. This phone. That's funny. Okay, let's put him over there. So here's my primaries. Here's my secondaries on this power supply. Let's do it. I'm just going to strip off the very ends, just like that. Now, if my theory is correct and 2 of these channels are burned out, that means that one of them will be at the full potential. And once we get that, then we can set it up in here on my regulated DC power supply to test out the bulbs. We need to know how much voltage it is. There's no indicators whatsoever on this board. Wait. No. Just says L2 plus, L1. There's no voltage written on this board, unfortunately. There is a small fuse, but we already know that we have power. Okay. All right. Okay. This is a silicone mat, so it is definitely a safer environment for doing this kind of work. And let's see. I do have other little vices so that I don't have a circuit board just floating around doing nothing. Okay. Hopefully this vise goes wide enough. I'll tell you what. Here's what we're going to do. We're going to switch up my vices because this one here has much larger jaws. And my little pano vise over here is going to get my AC. There we go. Never can have too many vices, guys. There's words for life right there. Okay, I'm still unplugged, which is good. So I can touch these connectors all I want safely. All right, now let's go ahead and widen these jaws. And I'm going to sit the PCB right here on these rubber standoffs. That will give me a much better platform for troubleshooting. Here we go. Okay, so I'll place him off to the side. Okay. Try and keep this linear so that you guys can see what's going on. Police my area. All right, guys. Time for some truth. Okay. So let's straighten out all my tools. Now, what I'm going to do is I'm going to use a couple of these little clips. That way there I get a stable reading. I've got test leads like all over my shop here. There's one. And let's see. Here's another one. Okay. So what I'm going to do is I'm going to connect my test leads to my meter leads, and I'll put those off frame. There we go. Okay. And now I can just connect up. Come on. Oh, this test lead is garbage. Okay. I just got through saying I've got all these test leads, and I proceed to use a garbage test lead. Okay, here we go. So what I'm going to do is I'm going to take these two leads right here, put our meter on DC. Hold on, move the phone right there. Now you guys can see it. Okay, so I'm going to go through each one of these circuits once it's powered up, and we're going to test it out one by one. Okay. Here we go. First one. Whoa, boy. Oh, boy. Did you guys see that? That is 172 volts. There's no way. There's no way. That's wild. Okay. 172 volts. Okay. Let's see if we have a common negative. If we do, 172 volts. And the third one, 172 volts. Is it possible that I have burnt out bulbs? Okay, let's see. So we don't have a common negative terminal. That's interesting. Come on. There we go. Okay. 172. 172 volts. I wonder what happens when we put a load on them if it sags. Because you can have 172 volts floating, but then it sags. There's no way those LED bulbs use 172 volts. There's no way. What the heck is going on here? I'm kind of curious if the system over here is going to be affected by having an isolation transformer. Kind of curious. Okay. Move those two over. Let me unplug the isolation transformer. Okay. And then I guess I will plug it straight into the mains. Again, not the safest thing. These guys here are separated, sort of. And I guess we're going to see what happens. Okay, you can see it bleeding off right here. That is actually these large capacitors discharging up here in the DC side. That's why you never want to grab a hold of a circuit board that's been powered off until you know that it's bled down. Goes to show you right there. All right, so let's take this AC mains and let's carefully plug it in and see what happens. I 164 volts. There's going to be a little bit of a difference because the windings on the transformer. But wow, 160. There's no way. Okay, so unplug it again. So it's saying it's 164 volts DC to power those little LEDs. That's wild. You guys think that that's accurate? Hey Hasib, how you doing, sir? Hasib, I have 172 volts powering some LEDs, and there's no way that can be accurate. That would be just wild. So I'm a little curious what's going on here. Very curious indeed. Okay, you can see it bleeding off again. Let's give it a moment. And I have my lighting fixture up here that we'll pull up. And I guess we will take a look and see if we can power the LEDs off of maybe 30 volts. Geez, they shouldn't even be 30 volts. That's wild. So this guy right here, I have 172 volts on each of these, which I'm not really understanding. Okay, it is what it is. That's what we measure. Let's go ahead and disconnect this guy safely. All right, and I will disconnect this guy. So you can see over here, this is how I do it. I take my IEC and then I put gator clips on each side like that. And that is how I can safely separate the two AC channels. And that's how I usually do these kind of AC diagnostics. But I'm thinking that I should have AC terminals or something safe here, maybe attached to my tabletop. This is a wooden tabletop. And maybe I have some safe leads that come out from a test plug. We'll see. I'll get better. Okay, guys. So our power supply looks like it's working. And you guys, I already have I have a known saying on my rules of repair, and that is, it's already broke. Might as well experiment and test it out. And that is exactly what we're about to do, folks. So I'm gonna go ahead and power up my DC power supply. Now this guy here, does this one go to 60 volts? I thought that this one only goes to 30. Yeah, I got 31 volts. Is what it is. Okay, I'm gonna turn the current all the way down. Let's go ahead and get some leads. Okay. Okay. Gotta get used to moving my camera target around. Okay, so I'm going to go ahead and attach my leads to my DC power supply. Set the tools to the side. Okay, guys. Now to use a DC power supply, first you set the voltage. Actually, you got to have a little bit of amperage to show voltage on this one. Some of them, that's not the case. Okay, so you can see I have it at 31 volts. My voltage is maxed out. This side over here is for amperage. We have a coarse and a fine knob. So I've got them maxed out on voltage. And for amperage, I'm going to turn them all the way down. And we connect these two leads. Okay. And then we will go ahead and turn it up just a little bit. Okay, so you guys can see right here, I got 1.5 amps. That should be plenty. 1.5 amps is more than enough to smoke some LEDs, unless they're really high voltage LEDs. That would be so crazy. Look at all this white powder. That's for that thermal compound. And it was so powdery that it just went everywhere. It's crazy. Okay, so my power supply is set at 31 volts. I've got those leads right here. I can get rid of these two. Don't need those anymore. My multimeter, and just set him in the back. And let's go ahead and let's grab some LEDs and let's see what we got. Okay. So we have these ones right here. Goodness, I see what they did now. So they put these in series. You see that? So you're going to divide the voltage by 2 for each light because they're in series. But that still would mean that they're like 60 volts DC. That's just crazy. There's no way. Okay. So we're going to clip all these so that we have separate LEDs. And that way there we can test them one by one. Okay. So here's my first one. You can see it's right there. Strip it back. It's going to be crazy if these are high voltage LEDs. Come on. Okay. So I don't know if that's this one or this one. I don't know if it's any of them. We're going to figure that out together. So I'm only shooting 1.5 amps. Here. Let's go ahead and connect that positive up first. And let's connect the negative. And I have nothing. I have absolutely nothing. Okay. Is it possible that we blew out a couple of our bulbs? Let's clip some more. All right. And if I need to, now that I know that they're all in series, I will just remap them. I'll do it again, which means I'll make wiring pairs and stuff again. Okay. All that garbage. Okay. So I know which ones I've tested and which ones I haven't. I'm going to do them one by one. I'll just strip one, then test it, and then strip one and test it. Okay. Next. I have absolutely nothing. How could that be? There's no way. Have you guys ever heard of a high voltage LED? I mean, I've seen it when LEDs are like in a matrix, like they're all in series, they create a voltage divider. But I've never seen it where we have like, it's almost like a Cree LED. Here, let me show you guys what it looks like on the bottom of one of these bulbs. Okay. So right here, you can see that we have 7 different LEDs, and they're probably in series. So we take the 60 volts and we divide it by 7 if they're in series. And that's what we're looking at, but geez, that's wild. I don't know which ones are these two. These are the only two that were lighting up. Remember that. So I don't know which ones those are. That's why we're gonna go one by one and test them. You would think at 31 volts, I would have some sort of illumination. Okay. I'm not showing anything over here either, by the way. So one of the things I do when I'm troubleshooting is you look over here on amps and watts, and it will tell you how much current is being pulled. And you can see I have no current being pulled by these. And I would assume that the polarity is correct. I assume that I'm doing everything correct. If hopefully they didn't do reverse polarity. We'll test it just to be sure, but that wouldn't make any sense. Okay. All right, let's do this one. Still have absolutely nothing. And my last two wires. I really need a higher voltage DC power supply, and I'm starting to see that now. Okay, let's connect this guy. Connect this guy. Still have nothing. I'm baffled, guys. Absolutely baffled. Last one. And this last one, I will actually connect also reverse polarity, just to be sure. I believe this lighting fixture I got from Lowe's, and it would have been a couple years ago, probably 2 or 3 years ago. I still have nothing, no current being drawn on this right here. So let's reverse it. Let's see what's going on. See if we can pull a dead short or something. I have nothing. And I've got nothing. Okay. Well, that is normally how you would diagnose LEDs, but we can already see that there's some special things going on with this guy. I'm going to take off the extrusion right here, and this guy is the heatsink. Yep, there we go. Make sure that there's no damages down in here. Oh, God. Look at, they put more thermal compound right here. Here, let me get that fastener out of there. Okay. So they put more powdery thermal compound here to the actual light fixture base. That's why it was always getting warm. But it's powdery. You see the powder everywhere? So it's garbage thermal compound. Okay. I'm going to put this guy down carefully so it doesn't make a mess of my desk any more than it already has. Okay. So these two are for those bulbs. I don't sense any thermal fuses. Many electronics will have like thermal fuses and stuff in line with the cables. I got none of that. So let's go ahead and let's take apart one of the lights and see if we can get some real answers. Oh no. Oh no. You guys know it wouldn't be a better Biomed video unless things go absolutely wrong. Okay. So these two over here, I like these ones. I got a little set screw here, and I've got a set screw over here because these are flexible. So let's go ahead and pull these two and take this guy apart maybe. Yeah, looks good. That looks good. And this one here is cross-threaded on from the factory. I love it. They just said send it. Okay. Let's go ahead and pull these guys. Let's see. Like this one. That's a 2.5. try a 3. Okay, I'm going to try and keep the components up here. Wow, what a mess. I don't really care if this thing is not repairable. I don't honestly care. But I am frustrated. I'm extrememely frustrated that, you know, modern day electronics are just designed to fail. There we go. There's a plastic set screw that's holding the flexible cable. There we go. Look at this spring. It's a cool aesthetic. Okay. And let's see, I've got a set screw right here. Nope. Is it glued in? I think it might just be glued in, folks. In that case, I'm never getting it out. Okay. What do you say we clip it, right? So what I'm going to do is pull all the shielding off. And I want to pull out that whole entire light, hold it in my hand. Jeez, what a mess. This is pretty invasive for a typical light fixture, guys. At this point, I'm committed. I'm committed. I can't let it beat me. Here's the housing. Yes. Okay, here's my wires that I was talking about. And what a challenge. Whoever it was that had to feed these up in here is an absolute champ. This is not easy, guys, because you got to run them through all these channels, and they're flexible. There's no commutators, which are points where the cables will connect and swivel. I do have my cables right here. I'm just trying to pull the shielding off. It is not going so well. Come on. Okay. There we go. Come on. There we go. All right, I'm going to set the light fixture down, because now we got some real stuff going on here. Let's police our workstation a little bit. Okay. You can see that this turns into a mess real quick, eh? All right, so I have one little set screw right here. I don't know what that guy's for. He's tiny. Like this. We're going to have to bring out the smaller tools, folks. Okay. And so this one. No. No. I don't, all the times I've tipped over my Allen wrenches, you think I'd have them in order. Okay. Put that guy over there. I have no idea what that set screw is doing. It doesn't look like it functionally does much of anything. Okay. So this should be right here at the joint, allow it to separate. Yeah. So this guy unscrews. And now I can pull my lights out. Yes! All right. Yay. Okay. Set these over the side. So this right here is my guinea pig. Finish pulling him apart. And it's very frustrating that I can't get in there. I've got a lens cover here. And what I might be able to do is pop this lens cover out. Do it that way. Come on. That's how I'm going to do it. Okay. And I have some people that always ask me, like, why do I have all these crazy specialty tools? And then you run into a situation like this and you're like, oh yeah, that's probably why. Because I've got some dental picks and stuff that I use to help me access some of these covers and O-rings and stuff like that. There we go. Okay. So it's a clear lens that covers the LED assembly. Now there is some more celastic right here all around, and it is old and dried, which means all we gotta do is trim it, which is what I'm doing with this tool. And then we can pop this guy out. Wow, that's not coming out easy. Okay. So it's like press fit in there. That's kind of annoying. Here we go. Now I just need to get a tool in there that's got enough strength to pry it out. Come on. Come on. Wow. That's in there good. Okay, guys. Well, I'll tell you what. It can be in there good. That's fine. Let's do some smoke tests. I cannot believe that I have no current. Yeah, I've got no current whatsoever on this guy. It says this is a 6-watt 2835 LED 1WC something or other. That is so annoying. This is all one piece too. I have no idea how to get that apart, guys. No idea. One would assume that it would screw together or something, but it's not. And it's very frustrating that I have... Here, let's just go ahead and turn the amps up. I'll turn them all the way up. Let's see if we got some light now. I got nothing, guys. It's 31 volts, and I have it set at like 10 amps right now on my overcurrent protection, and it is not doing it. Let's switch these guys around. This should make it puff into smoke. Nothing. Absolutely nothing. Well, guys, I'm limited by my tools, and I'm extremely frustrated about that. Are these really high voltage LEDs? So I get when you have them in series that it creates a voltage divider. But then I have 7 LEDs. Are they also in a voltage divider? So you're dividing it because the 2 bulbs are in series, and then each bulb has 7 LEDs. That would be wild, because if you pop one LED and they're in series, that would technically mean that they all go out, like both bulbs. Is that what happened? Like, I just popped one. I don't know. Don't know, guys. Okay, so let's see. Let's check for continuity. Okay. Okay, I've got nothing. I have nothing, folks. Let's check the other one that I didn't tear apart. What garbage! Okay. Let's check this one. Here's the wires. And I have nothing on this one. Okay. Let's see. Let me get my meter leads back. Okay. I think I do have something. So since they're LEDs, guys, you can always check them, but you have to make sure to test them with reverse polarity. And with reverse polarity on LEDs, you should have open or infinite. So I currently have nothing in this guy. Which kind of proves my point, guys. If they're all in series, so maybe my understanding is a little off. So here's the power supply. I have 3 separate outputs. Notice that the circuitry is really, really small. Now, often when you increase the voltage, you can decrease the amount of amps and you can use lighter components. But I'm kind of surprised by this guy. Why do I have 170 some volts on this guy? You wouldn't think it. At the most, I'd say like 12 volts or something like that. But where's the math? Here, let's do the math. So let's see. I had, let's say 160 volts divided by 2. So that's 80 volts per bulb. And then let's divide that by 7. That puts them at about 12 volts per LED. So what they did is they used 12 volt LEDs and they just put them all in series. But here's the problem, is if one on both bulbs, if one of the LEDs goes out, then they all go out and you will have infinite. I don't know. This is open. This guy here is still giving off voltage like a champ. But as I've shown in other videos, just because you have voltage does not mean you have amperage. I would have to hook up a load to this guy. What do you think? Should I go ahead and do that? Let's see. Let's see. I'm not giving up on it, guys. Here, let's move this guy over here. And let's go ahead and set up my AC for testing again. Let's move him. And my 2 gator clips, let's pull those guys back out. Okay. Camera, where are you? There we go. All right, so let's put this one here. Put this one here. Okay. And let's connect them up. Okay. And let's plug it into my isolation transformer. And what I want to do now, let's give it the smoke test. Let's actually hook up to one of these channels, my LED, and let's see if it explodes. Boy, this lead right here is absolute garbage. Did I say it's garbage, guys? I meant it. Okay, right there. All right. So that's this bulb right here. Good. Let's see if it lights up when I plug this guy in. How about that? You like that, guys? That was pretty bright. So the bulbs themselves are not bad. It's just when they're hooked up in series and one of them's bad, then both of them go out. That's very aggravating, guys. Well, I hope that this might have been a little bit informative, and if not, then at least maybe it's entertaining. I didn't get electrocuted. Yay me. That's a good thing, I guess. It's just wild that's how that they would do it. Let's try this guy, the one that we chewed all up. That light was so bright that I can't really see too well right now. Okay, ready? Camera, over here. Camera. Come on, camera. All right, I'm going to have to move the camera manually. Okay. I will do it manually. I don't care. All right. Let's go ahead. See, I've got this guy wired. 160 volts. Here's my light. Let's blast myself again. Check that out. Okay. Well, these were the 2 known good bulbs, because that's the side that I disassembled. So let's go ahead and let's disassemble the other side, and let's see what's going on with these bulbs. Okay, so I got these 2 right here. Wow, those are so bright, it blasted me. Okay. I'm assuming that's this one right here. Look at that. Case in point, guys. So, that bulb is bad. Let's try the next one. Okay, this one's good. This one's still good. Did I just have one bad bulb and they're in series? Nope, that one. Okay, so I got 2 bad bulbs and 2 good bulbs on this line right here. And if they were matched up in series like that, then when one of the bulbs goes out, you lose your current path, and that's why it's defective. Darn it. Okay. Well, folks, I think that is going to summarize this troubleshooting. Here, let's go ahead and zoom out. Okay. Okay, guys. So this guy right here is defective, and this guy right here is defective. Now, if I really wanted to, I could still salvage this entire thing because I know that I have 4 good bulbs. Okay. So that would mean that I would have to probably drop maybe these 2 middle ones, or keep these 2 middle ones and these 2 side ones and eliminate the side arm over here, which that's fine. 4 bulbs in one region. Maybe that's what I'm going to do. We'll see. I'll check and see how much this lighting fixture costs, but that is extremely annoying. And just so that you guys can see, right here, the little LEDs. See them right there in a little cluster. So they're 12-volt LEDs, 7 of them, 160 volts, and 2 bulbs in series. So that's how you figure them out. Anyway, guys, that was disheartening because I doubt that I can fix these since the LEDs are just cram-packed down in there. I could probably find which LED is bad. That wouldn't be very hard. I just set my switch mode power supply over there to 12 volts and then actually touch them, one by one, and figure out which one's bad and maybe replace them. But at this point, it's not really worth it. It's unfortunate, but just show you guys and to test the camera out. Really kind of interested with testing out the AI in this camera. I got to do better with the target tracking. It doesn't like dark objects, and obviously I'm reaching over, and that's why the camera lost its tracking. But maybe I'll create a light target, and then I'll move it around, and the camera follows it. It's a cool overhead camera, and it's also like a microscope, so I can zoom really far in, like circuit board level. I can zoom really far in and show you guys as I'm fixing things. Pretty excited about that, guys. But anyway, guys, that's some AC and DC troubleshooting. Do it safely, and if you're going to be testing with AC mains openly like I am on a workbench, use an isolated transformer. It's going to make it much safer for you. And none of us like getting electrocuted. So thanks for watching, guys. I hope that this was at least a little interesting for you. Okay, a couple of you guys are just coming in. I guess this is a good time as any to announce what's going to be coming up. I have a series of live streams. We're going to be doing it probably about every week, and it's going to be called Ask the Experts. And I'm going to bring in experts from across our field, and you can ask them whatever you want live, and they will answer the questions live for you. And it's going to be in conjunction with several large companies and colleges. It's going to be fantastic. I've been working on this for a long time. This is the first time speaking about it, but it's another reason why I've been producing videos. Very excited about it, guys. This is a worldwide initiative to help people learn and to fix their medical equipment. And it allows you guys to ask experts from around the world on exactly problems that you're experiencing. It's never happened before in our industry, not like this, and I'm very excited about it. So stay tuned for that, guys, and I do appreciate the support from you guys. 25,000 subscribers, and we're climbing. It's doing fantastic. All right, guys, see you all next time, and maybe by next time I'll have the medical devices shipped to me that are going to be coming in, and we will do live troubleshooting on actual medical equipment. Pretty excited about that one too. See you guys.